So hi all of you. Today I am going to discuss about the final year project that is done by my student. So project title is basically the design and implementations of MPPT controller, charge controller basically using Arduino Nano. So let's introduce my student that have done this project. Let's introduce my students.
Hi everyone, I am Vidya Kumari.
Hi everyone, I am Vishal Kumar.
Hi everyone, my name is Suman Kumar.
Now see, this is the hardware implementation. So let's introduce Vidya. What is the basic objective of this project?
The main objective of this project is to design a microcontroller based MPPT system, which is a maximum power point tracker. The basic purpose of this project is to recover the power losses incurred in solar PV system and enhance the power, extract maximum power possible and maximize the efficiency of the overall system.
Vishal, you just brief overview of this project. Okay.
So this project basically.
Okay, I am just showing the slide. You just explain one by one.
PV photovoltaic system. Basically, we have used Arduino Nano for the control of the pulse, that gate pulse that we gave to the buck converter, so that it will adjust the voltage, the outgoing voltage, so that the battery will be efficiently charged. The main purpose of this project is that when we give power, suppose the battery is of 12 volt and the power coming from the solar panel is 17 volt.
Okay.
And 17 volt 2.2 amps, then it goes to approx 34 watt power is supplying to the battery, but the battery is of 12 volt and and we get the power current 2 ampere, then it will just consume 24 watt and the rest of the power will be wasted. So the buck converter process is here that it will take the output voltage to the battery level and it will enhance the current, so that the maximum power should be transferred to the battery without any loss in the middle.
Okay. So you just see the slide. These are the literature review, na?
Yes, it's a literature review of the project, and then we have added some slide for the environmental concern, that why do we need this project.
Okay.
And the solar energy is basically of two types, solar photovoltaic and thermal. Here we are proceeding with the photovoltaic system.
Photovoltaic, okay.
And these are challenges, that are low conversion rate and the variation of the weather in the climate condition that adjust the factor of the solar PV. This is the block model of the solar photovoltaic system. Basically, solar panel is there, a charge unit, and the charge unit is controlled. Charge unit will give the pulse modulation and then it will charge the battery.
Okay.
And why do we need the converter? Basically, it is inverted there, that because the solar voltage that we get from solar is not constant, so we need to make it constant. That's why we use it. So, and this is the overview of solar charges, that how it works.
Solar charge controller. Okay.
Yes, solar charge controller. And this is the evolution of the solar charge controller. First of all, in 1990s, we were using on-off charge method using relays.
I mean, these are the conventional techniques that
yes,
previously used. Okay. On-off charge controller. Next is solid state series controller.
And now we are using microprocessor. That in our case, we are using here Arduino Nano.
Okay.
These are the modeling that we have performed in the MATLAB to get the simulation results. And this is the battery modeling and buck converter modeling.
You have simulated in MATLAB. Okay,
yes, sir.
Very good.
And this is the complete circuit diagram in the MATLAB, including the MPPT and the battery charging system. Okay. And these are the simulation results of the input and output voltage, input panel voltage and output voltage from the buck converter.
Okay.
And these are simulation results, and then we have given the scope waveform irradiation input in 4 different time zones. And the result shown on the right side is the result which is without MPPT, and the down one is when we inculcate the MPPT technique, then it has boosted the power. You can see that when the irradiation is up to 1000, it is giving approx 40 watt power. Our solar panel is a 40 watt, that's right. And this is the MPPT technique, that how it's work. It tracks the power and it just increase the voltage to check the duty cycle. If the voltage is increased, means the previous power is increased, then it will just increase the duty cycle, else it will reduce the duty cycle to get the maximum efficiency. It will just track where we are getting the maximum power.
Okay. So next hardware implementation. Okay. So hardware implementation, you just explain the different parts and also from where we have purchased This is very important because some students from anywhere, any university, suppose they want to implement this model, then basic issue is that the rating and the equipment from the where they purchase. So if you have any link or anywhere purchase, just explain the details of all the hardware equipment that you have implemented here. You see all the students or those who are watching this video, the students will explain all the details. So Vishal, can you explain or you just explain any part?
Most of the equipment we have bought from local market, and the rest of the
means local markets the equipments are available.
yes,
So it
most
depends-
of the equipment are
So it
available in
depends.
local market.
It depends on city if it is available or not, or most of the equipments are available in India Mart.
India Marts or Flipkart, Amazon also, na?
Yes, sir.
So okay, so you just explain the rating and the equipment names, the device used. That's a help for the student because they are not available in local market, but the rating is available, name is available, so they can search in the India Mart or the Amazons. They are easily purchase from that sites. Okay, so just explain the details of the equipments.
So we are using here a solar panel of 12 to 36 volt of power output. It depends on the solar irradiation, and it has a output power of 40 watt. And then we are using a lead acid battery which has a capacity of 12 volt and capacity of 7 ampere hour. And the microcontroller that is used is Arduino Nano. Its name is ATmega 3328P, and the current sensor.
Just point out from this pin.
So this is the Arduino Nano controller that we are using, which is ATmega 328P, and this is the current sensor that we are using, ACS 712, which is rating is of 5 ampere. It operates at 5 ampere current, that input voltage that should be provided, which is given from the buck converter that we are using here. This buck converter is basically taking the battery power from 12 volt, converting it to 5 volt and supplying it to the Arduino Nano and current sensor. This power is basically for the working, means the device is on, and the input voltage that is coming from the here is 5 volt, and then we are using a relay here over here. This relay is, the purpose of this relay is to basically on and off the current when our program is such a way that when the battery voltage is above 80%, then only it will supply to the load, else it will just cut off the load to prevent the extra drainage of the battery. And we have used here the MOSFET, that is IRFZ44NBF, and the resistors are used as a voltage divider, which is 7 kilo ohm and 1 kilo ohm, and a capacitors of 470 microfarad. Sorry.
Okay. So what we have observed, and the result is very important for any project. So can you explain what we have observed from this data display and any plot and any graph? Then this is also beneficial for the student, those who are watching. So what have you have data? You have, this is the MPPT controller, basically maximum power point tracking. Okay.
Yes, sir.
So basic purpose is to track the maximum power when the time or day by day utilized by the solar this PV panel. Okay. And now this we have to control by using this controller. So what we have observed, what are the experimental data that we have collected from this experiment, just to explain for the students.
So this data was taken on 5th June 2024, and we have taken the data from 8:55 AM to 5 PM. At different times we had observed the voltage and the current of the PV panel and the load that we have here. In our case, the load is the battery because we are charging the battery. And we can see that from 8:55 to 5 PM we are taking the observation, and it is found to be that average efficiency that comes out to be 96.03%.
Okay, this is 96.03.
Yes, sir.
Okay, what are the plots? Just one of the plots.
So these are the plots, that the graphical representation of the data, that the input, the blue one indicates the panel voltage, panel power, sorry, and the red line indicates the load power, basically, which is the battery that is supplying to the battery.
So now I hope that observations and the plots are very clear to all of you. So Vishal, just tell me the display and what is this actually. display.
Sir, the display basically indicates, it has two columns. It will indicate, this column will indicate the voltage coming from the panel. Currently we are in shooting this video indoor, so it's showing 0 voltage, and this side shows the battery voltage. Currently it's 11.55 and the load is on. As the program is done that when the battery is 80% charged, it will show the load on. And this pulse width modulation shows that how much gate pulse it is given to, the Arduino Nano is given to the that buck converter we have designed here. And in this side we are showing the condition of charging, that is bulk, absorption or float, that will be shown here. And this is the current coming from the panel. And this is basically the ESP32 module. The entire work that we are done here can be monitored online from anywhere in the world. So this module comes with
basically online monitoring system.
Yes, sir. This module comes with the Bluetooth and inbuilt Wi-Fi.
Inbuilt.
Yes, sir. Bluetooth and Wi-Fi inbuilt. We are using here the IoT integration that works on Blink software. From we can see from the our phone or laptop from anywhere in the country.
So okay, very nice. So just wait. So Vidya, just conclude this project.
So the basic idea of this total design is to enhance the existing the performance capability of the existing solar PV system and making it more relevant to home needs, industrial practices, and the addition of LCD display system and Wi-Fi module makes it more significant, and it maximizes the efficiency of the existing solar PV systems which are available currently.
So very nice explanations by the students. So I hope that those who are watching this video, very helpful to build that type of project, or if any types of difficulty, then you just in descriptions all the details will be given, ratings, all the parameters, all the things will be given in the descriptions of the YouTube video. So thank you all of you, those who are watching, and thank you all dear students. Thank you.
Thank you, sir.
Thank you.